Good morning, everybody. Congratulations on getting here at 9 o'clock on a very wet day compared to yesterday. Thank you for being here. So this session, we're going to be having a conversation around the intersection between nutrition, human health, and soil, particularly making reference to the antimicrobial resistance, which is known as AMR, that is prevalent now throughout the world, and the role that farming plays in this. We're going to hopefully hear how deep the problem is, but from Maria, and then hopefully we're going to have some suggestions of what we can do about it. So I'm thrilled to have Maria Ortino from Legal & General Investment Management with us. She is the Senior Global Manager of Stewardship at Legal & General, and she'll explain what that means. And she was also a member of the Access to Medicines Expert Group on Antimicrobial Resistance, and she's also co-chair of the Access to Nutrition Investors Group on Nutrition and Health. So she's extremely well positioned to talk about this subject. The other conversationist is Jeff Allen, and he has been in this field for about 15 years. He is the founder, with his wife, of an organization called Microbes, and they've been making soil-based liquid probiotics for human and health and household cleaning for about 12, 13 years. And they're now moving into agriculture because it's Jeff's passion to educate every farmer that they can actually make their own soil-based microbes and you don't need to use chemicals on your farm. So that gives us our two positions here today. And so I'd like to kick off with, first of all, why are you here, Jeff, at Groundswell?
Oh, I'm here at Groundswell. This is the second or third time we've been here. I think this is the, a great opportunity for us to, demonstrate some of our solutions and being amongst like-minded people that are interested in finding ways to farm in better ways.
Yeah. Maria, it's a little bit strange for you. She said to me earlier, I don't think I've ever been presenting in my wellies and a Mac. So over to you to explain why you're here. Thank you.
Yeah, hi, good morning, everybody. I'm delighted to be here and to have been invited. It's the first time I'm here, and I think it's the first time the company that I represent is here as well. Can I ask a question to the audience?
Of course, go for it.
So to explain, so I represent LGIM, so that's Legal & General Investment Management. And if I ask you, how many of you are saving for your pension? Anybody saving for their pension? Very good. Are you doing it by putting cash in a bank account that you hope interest rates will rise on? Or are you doing it via a pension fund? Or don't really know? I said, yeah, very good. So what we do, and is this a good time for me to explain what we do? Yeah.
Go for it.
So the majority of our clients are pension funds, and we receive money from the client, and then we invest that money so that when you retire, you will have a retirement pot that you can live on for the rest of your life. Investing that money, you do by putting them in shares, so you buy shares of companies, you can buy government bonds, and in infrastructure, put it very widely. And so the stewardship team within which I work, we work with the companies in which we are invested to raise the market standards, you could say, and best practices. Now, how is this connected to our conversation today? It is because I lead on our health theme, and within our health theme, we work on nutrition and antimicrobial resistance because we see those as big systemic risks, which will have if we don't help companies to deal with them, will have a significant negative impact on your pension pots in the end. As in, there will not be money in your pension pot to pay for your pension. And that you could draw a parallel with climate change and how that will impact how companies operate and how we live our daily lives. So I think I'll leave it at that for now.
Brilliant. Thank you. So I'm hearing that antimicrobial resistance is a systemic issue, and it's impacting nutrition, which is also a systemic issue. Great. Okay. So, Maria, what exactly is AMR, or antimicrobial resistance?
Yep. If we can take the first slide, maybe. I don't. If you know what it is, then please bear with me. Most people don't. So antimicrobial resistance is when let me restart. Is the products that you have to kill, for example, bacteria, viruses, fungi, and parasites. The easiest to explain it is via the usage of antibiotics. So you have an ear infection, you use an antibiotic, and you're cured. For example, you're undergoing cancer treatment. People who are undergoing cancer treatment are highly susceptible to an infection. In order for them to be able to continue their cancer treatment, they need to treat any infection that they get during the cancer treatment, and you do that via antibiotics. If you throw yourself, well, not you, but if you think of your family, in the beginning of the 19th century, the majority of deaths occurred because you didn't have antibiotics and because of infectious diseases. So antibiotics underpins our modern medicine, basically. So from the 1940s onwards, when you look at death figures, you will see that the reason for death is no longer infectious. The major reason for death is not infectious diseases. So that's to give you a bit of background. Now, AMR happens when the bacteria becomes resistant to the product, as in this instance, antibiotics, and is no longer effective. If you look at the first circle, you'd have the majority of the light orange is the bacteria that dies because of the antibiotics. The two orange ones are the resistant ones. If you go to the next picture, you see the ones that are very light yellow. Those are the ones that died because of the antibiotics given, and the resistant one stays. Now, in the third picture, the majority are resistant bacteria. And the resistant bacteria will multiply. And that's how the increase of the resistance. So the resistant bacteria multiplies. Now, bacteria are much more intelligent than human beings. When you transmit your DNA, you do it from yourself into your children. Now, bacteria, they're very clever. They can do it that way, so vertical transmission, but they can also give resistance, colloquially speaking, to their cousins, their neighbors, and actually also their friends down the road. And that's how their resistance spreads quite quickly. And that is what AMR is. It's that resistant. AMR is also relevant when it comes to viruses, fungi, and parasites, but it's particularly prevalent and dangerous for the human health when it comes to bacteria and hence infectious diseases. Does that, Katie, have I explained that?
I think that's great. All I know is when I take antibiotics, which is very, very rarely, I will have a probiotic afterwards. So maybe we can come on to that in a while, Jeff. So you were talking about the spread of this AMR, and
so
I think this is quite key.
Yeah, this is a really messy picture. I'm afraid you see it well when you have it in front of your desk, not when it's projected like this. So AMR, so what we think about often is we take the example of antibiotics. So we think about it in human health. We take an antibiotic, you have an ear infection, take it for 7 days, then you're fine. As Katie said, you maybe take a probiotic afterwards, and that's the end of the story. The majority of antibiotics are not consumed by human beings. It's in animals, and in animal farming in particular. And so if you look at the global figure, so it's not representative of the UK, but on a global level, more than 70% of antibiotics are consumed in the animal husbandry industry, and 30% by humans. AMR doesn't distinguish between human and animals. So the resistance increases with the usage of any type of antibiotics, which means that the effects of an AMR comes back to us as human beings, as in we come to a point, and unfortunately we're already at that point, where there are infectious diseases that we can no longer treat with antibiotics because we don't have the antibiotics to treat it. And you will say, well, we'll ask the pharmaceutical industry to produce some more. Or develop some more. And that usually, just to give you an idea, to produce new antibiotics, it takes about 10 to 15 years of trials before we can actually consume it. So just keep that in the back of your mind. What this picture demonstrates is the uses of antibiotics and how that spreads and increases the level of AMR. So you use it in animal or in human health. The animal, if it is not for your dog but for cattle, that antibiotic, either a small percentage stays in the body and we get it if we eat it or in the milk. The majority of antibiotics used in livestock, between 70 probably, and 90% is actually excreted afterwards. So via urine and feces, which means it comes into the soil and into the water. And that's how you see the flow, how it impacts the soil, which Jeff will talk about, and also our water system. The manufacturing of the antibiotics that are for us, but also where the majority of them are sold into the animal husbandry industry. So the manufacturing plants will also leave in their water system antibiotics residue, and which means that antibiotic-resistant genes and bacteria comes into the waterway and again back into the water that we use and into the soil. I hope the picture again is a bit cluttery, but I hope that gives you an idea what happens.
I'm just taking away 70% of global antibiotic use is in farming, in livestock, really.
Yeah.
And up to 90% of antibiotic gets leached through the animal into our ecosystem.
Yeah, exactly.
Which is why AMR is a systemic risk, not just for humans, but for the whole of our nature and our land and our ecosystems. Right, okay. So turning to you, Jeff, what's your understanding of AMR, or how has it influenced any thinking you've had at Microbes?
I think for us it's kind of looking at the basics of how our attitude towards bacteria generally. You know, one of the things you hear so often on TV when they're selling you a kitchen cleaner or something like that, they go, kills 99.9% of all known germs. And probably it does to some level. But then the next question is, the ones that survive, what do they do? And what they do is they go away and start mutating in order to be able to survive the next chemical attack. So by using those kind of cleaners, by having that way of thinking, what you're doing is you're just forcing bacteria, forcing nature to mutate into being able to survive all those chemical cleaners. So they're just getting angrier and stronger, and that's the whole problem right there. And one of the things that I've learned about microbes, to really understand microbes and microorganisms, it's not about killing anything. What it is about learning about balance. See, about 0.5% of microbes are pathogenic. 0.5% of microbes are probiotic, are healthy. The 90% in the middle are opportunistic. They go to whichever one is in the majority. That's why when you get food poisoning, you get sick really, really quickly. Because what's happened is all your microbiome has all gone and joined the other gang, you know, the strong one. So now they're really working against you. So what you need to do is to get well, is to then increase the balance of the probiotic microbes, which will then mean that all the opportunistic ones in the middle will move in your favor. And that's the same with your soil. And that's the same with any microbiome, is to get that balance in there. So quite often when we're dosing, sometimes we make a cleaner, for instance, that cleans with microbes. But the dilution is 1 to 100, which is just a tiny amount of microbes that you need in there in order to clean your environment. So what you're really doing is you're getting all the other microbes to work with you. So then, you get a much better outcome. And those negative microbes will always be there. I mean, they actually serve a purpose. But it's our attitude to thinking we can go in there and kill them all. Because we can't, and if we did, it would kill us.
So this is something about, we've talked about how the overuses of using antibiotics is contributing to this rise. But I just want to understand a little bit, how many people are affected? Are there any figures about the deaths that AMR is causing? Because you hear often about somebody going into hospital and getting sepsis or getting MRSA, and you understand that is because of the rise of AMR. So have you got any figures to share to just help put this in perspective, please?
Absolutely. So I'll give you a bit of an historic to also to indicate how the rise of AMR kills human beings and how we can see that projection estimate going forward. So a big study was done in the UK around 2014 and published in 2016, where the estimate on a global level was that we had 700,000 deaths per year globally due to AMR, specifically to AMR. In bit before 2019, a study started by the Global Research AMR project looking at all hospital records globally from 202 countries and territories to see the reasons for deaths. Some were obviously you needed to do estimates, but it's a really thorough study which indicates that in 2019, you had 1.27 million deaths due specifically to bacterial AMR. So not fungi, parasites, or viral, but due to bacterial AMR, and they were caused by AMR, and which means that there were no antibiotics available to treat those specific infections. That's a very high number. The indirect death reasons due to bacterial AMR were calculated to be 4.95 million deaths. If you throw your mind back to a year ago or 2 years ago when we were in the midst of the COVID pandemic, the death figures for COVID on a global basis over 3 years were 6.6 million deaths. And if you then take a further step back and think what happened to our economies and the global financial markets due to COVID and the impact it had on us as individuals, but also on companies and pension funds in the end. Now, the figure that was estimated in 2016, although 700,000 deaths, were if we do not take action on AMR, the human impact will be 10 million deaths per year by 2050. So on an annual basis, you have 10 million additional deaths due to AMR. And then remember the number of 6.6 million deaths of COVID and over 3 years. That's a huge number. And so action really needs to be taken now and onwards to stem those figures, but more importantly, stemming the rise of antimicrobial resistance.
Okay, so that's a lot of deaths. But moving on from deaths to nutrition. The Global Nutrition Report, in its latest version, has moved from talking about a double burden of malnutrition, which is undernutrition, overnutrition, think obesity. The third element, which is new, is called micronutrient deficiency. And that's being seen as one of the causes of increasing levels of dementia and Alzheimer's and neurological diseases like Parkinson's as well, and potentially even ADHD. Can you explain why AMR is linked to this rise in micronutrient deficiency? Either of you, please.
Yeah, I think what I would say in a really simple way is that we've sort of lost contact with nature in some ways. Like the food that we're eating, the food that we're growing, it's just not as nutritious as it used to be. And then take that food and start putting it into ultra processed food, then even less nutritious, and it's basically not healthy for us, because the microbes that it contains are not beneficial. See, our microbes come from the soil. The soil gives us our food. And so it's that link through there. If you've got a healthy soil, then what comes through that is all that microbial part of it as well. That's the part you don't see. And some people say if you want to get a really good microbiome, you need to eat about 30 different vegetables a week. If you sat there and calculated how many different vegetables you eat in a week, very few of us would hit 30. But each variety of vegetables has its own microbiome, has its own microbial structure. And we kind of need all that to build our immunities, to build our resistance. Because our immunity comes from our microbiome. And when we don't eat well or we don't eat beneficial food, the first thing that goes is our immunity. And then we become susceptible to all these diseases, and we get malnourished and overnourished. It's just, we stop working. Our body doesn't work. Our body works because of our microbes. The microbes are where we came from, and the microbes are where we're going back to. So we need to re-establish that connection.
But going back to the micronutrient deficiency, you said that the food we eat today is less nutritious than it was before. Is that because of the antimicrobial resistance that has leached into the soils and the water systems? How is that impacting the nutritional content of the food?
I think it's across the board. I don't think you can go to just the antimicrobial. That's a contributing factor, but it's just like the mineral content in the soil is not what it used to be. The products coming out of there, even sometimes good organic food doesn't contain as much mineral matter as they did 50 years ago, 100 years ago. We really need to go back to basics on a lot of this stuff.
So if that gathering of microbes, going back to Maria's early slide of the 4 circles, so if we're in the 4th circle in the soil, we don't have the balance of microbes in the soil, and therefore when the plant is sending its messages down its root system saying, oh, I need a bit of boron or something, the microbe doesn't exist there because it's AMR's wiping it out, potentially.
Yeah.
So then the plant doesn't get the boron and we don't get the boron.
Exactly, and you're imbalancing the whole thing. It's like, now we're infecting our microbiome, which is the basis of our survival.
Do you have anything you want to say on that, Maria?
No, I think Jeff covered it really well. I would just, I think, add is how the usage in animal in the animal husbandry or in the livestock industry, if you want to call it that, does have an impact indirectly into the soil, because it's used in the animal. The animal will excrete it, and it comes into the soil either via the water system or because of going directly into the ground, or the manure used afterwards on the fields. And again, I think it's not to say a specific UK direct issue, because the levels of AMR stewardship in the UK is probably world leading. I don't want to say that as a fact, but relatively speaking, the UK is much more ahead. But that's on a relative basis, and I think it's important to be aware of that on a global level, because it does have an impact on us here in the UK.
So before we move into looking at what we can do to prevent AMR getting worse, what we can do to as sort of solutions to it, any questions from the audience on what AMR is and how it works, or have we covered that? Okay, a hand over there. Please could I ask for a roaming mic? I think Sophie's on that. She's just coming. We've got a lady over here and then a gentleman at the front.
And the lady.
Oh, and another lady there. So we'll take 3 questions now. Thank you.
So am I to understand that if this is happening with bacteria, it's also happening the same with funguses and archaea and protozoa? Not protozoa.
Yes. So parasites,
Yeah.
fungi, and virus. Yes.
This gentleman here. Thank you, Sophie.
Just, you mentioned that Britain is far ahead relatively compared to the rest. I think 35 years ago I was milking cows in Denmark, and if we had a cow with mastitis, I couldn't inject antibiotics. The vet had to come out and do it. You know, they were Scandinavia seemed so much tighter on their antibiotic use 35 years ago than we are now.
So, as I said, I wouldn't say it as a fact. I think, relatively speaking, if you compare the UK to, for example, the US or China, if you compare the UK to the Scandinavian countries, then most likely they will have a better AMR stewardship and the animal. I guess so. I should have caveated it even more. When I look at AMR from a institutional investor point of view, and what companies do I focus on, where can I put pressure and say you need to change your practices, those companies will be located in the US, for example, also in the UK, in China, in Brazil. Yeah, I should have caveated that.
Could I ask another question?
Please.
You're talking about soil, about the soil biome. Am I right in thinking that Roundup was originally developed as an antibiotic? So by the use of Roundup, which is spread especially with GM crops, we're actually altering the soil biome as well.
I would say, I'm not. Yeah, I would say so.
I didn't know that was initially created as an antibiotic, so thank you for that. Didn't realise. Thank you very much for that. The lady just behind. Last question at this moment for clarification on AMR.
Thank you. Would you agree that cheap food isn't really that cheap when you take into account the consequences?
No, I'd absolutely agree with that. Yeah.
Yeah, I would say that.
So why aren't our regulators helping? You know, it seems like we've had a push for cheap calories at the cost of nutrition.
Well, maybe that's a good time for Maria to talk about what they are doing at a policy level with the AMR groups in Europe and globally. Would you like to mention that?
Yes, sure. So we work on, and I would say also on nutrition. So we work with the AMR Action Initiative, and that's a lot is the policy work of getting countries to implement their national action plans on AMR. And those action plans, so in 2015, the World Health Organization World Health Assembly, so the deciding body of the World Health Organization, took on board or mandated that all members would draw up national action plans on AMR. And that was, so at national level, what are your individual structures doing? So looking both, obviously, to the whole healthcare services, but also on farming, and requiring then on an individual country level to both do reporting, but more importantly, have policies in place and ensuring that those are followed with specific guidelines. Those are individual to each country. So that's one part. What we can do as investors is saying you need to make sure on an individual country level that you're actually A, drawing them up, and B, making sure that they're implemented and followed. So we do work on that. We also ask the G7, both the health ministers and finance ministers, to be taking into account and do work, and more importantly, ensure that there is funding for AMR stewardship. On the nutrition side, we work with the Access to Nutrition Initiative together with other investors in pushing particularly consumer countries like companies like Unilever, Nestle, in looking at their product portfolio and how they can change that.
I also understand that one of the roles of institutional investors that really can impact companies is when you raise shareholder resolutions. And I believe you've done one recently on AMR. Would you like to just talk about that, and then people can explore more before we move into some solutions?
Yeah. So what we did together with two other investors was file a shareholder resolution at the annual general meeting of McDonald's, where we asked that McDonald's adopt throughout their supply chain the WHO guidelines for medically important antibiotics for the animal farming industry. So basically saying to McDonald's, you need to ensure that all the suppliers that you have apply the WHO guidelines on the usage of antibiotics, and in particular on those that are identified as medically important antibiotics for human health. That is currently not what McDonald's does. So that was our ask for McDonald's. And that is one way we as investors can push big multinational companies to change the way they operate, both themselves, but also the supply chain. Now you will say, what's the impact of that? That's a long, it's not a 100-meter sprint, it's a marathon, and ensuring that we put pressure on them to do that.
So could we also say to everyone in the room who's saving for their pension that they should ask their investment managers what they're doing about AMR, if some are doing it? And then potentially, I suppose, we could write to our MPs and ask them to make sure that we're making England follow the national action plans of AMR.
Absolutely. I think that's the most powerful thing that you as an individual can do, is actually saying to whoever is managing your pension, say, what are you doing on AMR, because it concerns me, the companies in which you are investing. And that's it. And the same thing can be done on climate change, for example, to challenge them on that.
So we've got this damage out there. It kind of feels totally unseen. 90% of antibiotic use has been leaching into our ecosystems. Jeff, you work with different partners around the world, and I understand some of them have got some solutions to this, or have found through their practices that they have solutions to this. Would you like to share some of them with us?
Sure, let's go ahead. Yeah, this is, let's talk about chickens to start with. This is, some of this information comes from our European partners, where they've been using probiotics, microbes, for quite a number of years in their broiler houses and things like that. This is obviously a chicken shed, and let's go on to the next one.
But what do they do with that chicken shed?
We'll move on.
Okay.
Yeah, we'll come back to. So basically, the point I wanted to make, rather than tell people what they're going to do with their chicken shed, is to tell people that actually, the health of your animals, whatever they are, is a kind of reflection of your vet bills. So I'll talk quite a lot about vet bills. So here we are, the broiler chickens, and this is treating these chickens. You can see the 32K chickens and the couple of cockerels in there, and the cost for them to feed that house with microbes and biochar comes out at about 16,000 euros to buy, the microbes and the biochar. Then we get into the savings. So one of the main things that we get once we swap over to a microbial, feed microbial way of looking at it, is we get better food conversion. That's one of the main dynamics that we find with any animals. When they get their microbiome right, you get better food conversion coming through. Then the higher level of fertilization of the eggs, less deaths per shed, and much lower vet bills. So this is the figures that come out, and it gives you an indication of the savings you can make if you swap to a microbial solution. There are certain dangers in this. I'll tell you a little story, just in case anyone wants to rush out there and convert their chicken sheds to microbial feed. In Germany, actually it was in Austria, they had 30,000 chicks in a house, and they said, oh, we're going to swap over and feed them microbes and you're going to live happily ever after. And the next morning they all came back there and all the chicks were dead, which is, So what had happened is as they swapped over to because you feed them through the water supply, the food, you spray, you aerate with them. Anyway, as the microbes went through the water supply, because it had been there for quite a number of years, the microbes cleaned the pipes and removed all the buildup of sort of toxins and stuff that had been in the pipes for years. And of course, what came out the other end wasn't a healthy microbial feed, it was a toxin. So just be careful if you're going to swap.
So how do you avoid that? You sort of swap it, have a gap?
Yeah, no, you just pump microbes through, just circulate it until you know your pipes are clean.
What's that, a couple of days?
No, a few hours.
Oh, right, okay. So you do it when you're in your cleaning phase. Okay.
So, and the ongoing benefit from this is because you're using microbes in your feed, and then that all those microbes then go into the manure. So then the manure becomes more healthy. Another big indicator is all that ammonia smell starts going, and the whole environment becomes healthier and healthier because that's what the microbes do. They create a healthy environment, and the same as a healthy chicken, same as a healthy person. So you benefit all the way through. So the manure doesn't smell so bad. It's that whole thing you say, if something smells bad, the reason it smells bad is because it is bad. But when you apply microbes to something that smells, the first thing that goes is the smell. And the reason for that is that you've changed the process from a putrefaction process, which that smell, to a fermentation process, which then has no smell. So it's a quick way of treating a slurry pit. Is if you add microbes, you'll know the microbes are working because the smell's gone. And that's the same in the chicken shit, anything like that. You know now, oh, this is a fermentating product, so it's much healthier.
I'm intrigued by this last line on the slide. Chicken dung now smells of forest soil.
Yeah, it does.
That sounds incredible.
Yeah, the farmer next to us is chicken dung does not smell of forest soil.
So you can become friends with your neighbours if you're chicken farmers in this way?
No,
okay.
They use quite often, like in composting plants, and a friend of ours in Spain, he had a composting plant. He had a lot of complaints from neighbours about the smell. And the day that he swapped over to applying microbes was the day all the flies went, all the smell went, and the whole thing was fine. And he now has great relationships with his neighbours. And, if you want to go out there and spread your dung or manure and you treat it with microbes before, you won't have all those complaints.
So we wouldn't have the problems we have with the River Wye and the Wye Valley if the chicken sheds there were potentially utilising this route?
Yeah, you'd need a lot of microbes to sort that out, I tell you.
Anyway.
We'd be producing microbes for a long time. Just in water courses, they use a lot, and they use microbes in fish farms and things like that to clean the water.
Okay.
And it helps also to aerate the water and things like that, so yeah.
So this slide, can you just explain the detail here?
This is just a farmer who was, fattening cattle, and then the use of, over a number of years of, that was the use of antibiotics in his herd, that how much they were using in a fattening cycle, And then at some point in 2014, they started introducing microbes into the feed, into the water supply, and also beginning to spray it. I think we have a slide on there. And it took about a year for it to start, really noticing the difference. And then after a couple of years now, they don't use any antibiotics. All their supplements, additive, are all microbial, probiotic ones.
Wow.
And also biochar is an important carrier. What we say about biochar is it supplies the hotels for the microbes, so for somewhere for them to live. So biochar is an important part of that feed.
Well, that's amazing. Look,
Yeah.
the reduction.
Oh yeah, I know there are people out there that says you can't do it without antibiotics, and it's really everyone has to make their choices. But there's growing amount of evidence to say you can do everything that you were doing with antibiotics with probiotics. We did another study in Spain with pigs, and we didn't get the translation done in time. But when they were raising them, it was they had pigs on antibiotics and zinc oxide, and the test ones were all done with microbes. And in the end, with the food conversion, the survival rates, the weights, and the general health was about the same in both of them. But of course, from one you hadn't used any antibiotics. It's not quite true. A couple of pigs did get sick, and so it's like all of us, if you get really sick, you should take an antibiotic. But don't think it's going to
Maria,
be
please.
the answer.
Yeah, if I could echo and expand slightly on what Jeff just said, is it's important to remember when we talk about AMR and the usage of antibiotics in the animal industry or livestock industry, is that it's often sold by the animal pharma company as, what Jeff was saying, as growth promotion. So you will have 25 kilo bags on it which says for animal feed growth promotion. And if you think, I am not saying that this is exactly what McDonald's, but say a big multinational company purchasing beef, in their supply chain, you will have smaller farmers who might, in perhaps developing countries, or will not have a background to understand that in that bag is actually containing antibiotics. What they say is, I've got a 25 kilo bag and it says growth promotion. If my chickens or beef grow, I will be able to sell them at a higher kilo weight. And that is a big problem, and that is where we also try to intervene. It's the growth. And also, if they are advised, if you have in your herd a sick cattle, you should be feeding the whole stock with antibiotics to prevent, so on a prophylactic basis, that the other animals get infected as well, or metaphylaxis, I think is the correct term. That increases the prevalence of AMR as well, and that is often what farmers are told. And if you use, just as a last point, if you feed that antibiotics, you think of the little pill that you take individually 3 times a day, what they often are served as in the troughs. So you put it's a soluble substance, and you will know this more than I do. And in the troughs, if you then having that, so all animals are feeding or drinking from the same trough, you are, in a sense, contaminating the whole herd, plus the trough that's then not cleaned maybe properly afterwards. So you got antibiotic residue in the trough afterwards as well. And I think that's important to understand why individual farmers may be using antibiotics on a completely different level than it's intended for. And just the really last point is, of course, antibiotics should be used on individual animals if they are sick, just like we use them when we are really sick and are supposed to be using them. It's important to remember that.
So the prophylactic use, but what I'm picking up here also is corporate marketing tactics, which I remember here last year there was a hot debate around the food companies. Yeah. So interesting that's in ag. Yeah. We've got a hand raised. Okay, we'll have one quick. Okay, go for it. Let's have some questions now. I do have a few other examples that we could share. Thank you.
Yeah, thank you. It seems to me that you're not going to deal with the AMR program at source without talking about the role of the pharmaceutical companies, which incidentally probably make good institutional investments. At the moment, the way these companies probably make money is to roll out existing antibiotics, whereas I think what you need is a system in which they're rewarded for developing new antibiotics, but not for selling as much of them as possible. So perhaps the production and sale of existing antibiotics needs to be done in a different way involving the public sector.
No, it's an excellent question. So it's important, I think, to distinguish. You've got the human health pharmaceutical companies, and then you've got the animal health pharmaceutical companies. And there is, some of them will be both. So there will be a subsidiary of a human health company that sells also animal health. The majority of them today, of the big companies, they are separate entities and use separate trade bodies. That's also important to remember. The human health pharmaceutical companies, so for example in the UK there exists a mechanism just recently adopted on what's called pull incentives, so where the state will guarantee X amount of money for provide funding to pharmaceutical companies that they do so research and development for new antibiotics, and will so provide initial funding and guaranteed funding on final products independently of the usage or the purchase of final products. And that's really important for the pharmaceutical companies in that they are guaranteed funding rather than depending on how many antibiotics they sell at the end of the R&D cycle. So that is something that we have here in the UK. There is another mechanism in Sweden, in the US, under the Pasteur Act that's been up for a vote just before Christmas and hopefully is coming up again, where the same type of mechanism is being proposed to incentivize pharmaceutical companies to do R&D when it comes to antibiotics. What we would say is that they should be concerned about it also because of their other product lines when it comes to cancer treatments, for example, because you can't treat cancer or undergo chemotherapy if you don't have the backstop of antibiotics. So we say there's a link there as well on that.
Thank you.
I would just like to add something about antibiotics in general. Antibiotics, what they do is, what it says on the tin, they kill your microbes. The thing is, they don't differentiate between your good microbes and your bad microbes. You take an antibiotic, you wipe out your microbial system. The common knowledge is if you wanted to grow your good immunity, a good microbial kind of microbiome that really supported life and things like that, it takes about 2 years to develop it, with a really good diet and taking a good probiotic. So the repair time is actually quite long. You can't just go and take a week's worth of antibiotics and then take a week's worth of probiotics and think you're back to normal. That's kind of not how it works. I mean, antibiotics are very effective at wiping out all your microbiome, the good ones and the bad ones. And that's why sepsis is such a problem now. It's increasingly, people, they appear to have survived their surgery, everything's fine, they're coming out of hospital, and suddenly they get sepsis and they're gone. And what happens is, because their whole microbiome has been nuked to a point where they have no resistance anymore. So, antibiotics are good and useful, but don't think at any time that they don't cause a lot of change to your microbiome.
And so if we take probiotics as humans, we should be encouraging the probiotics within the animal industry, which will help stop the spread of AMR. And will it actually reverse it? I mean, have you got any examples of that, or?
Did you want to do the other questions, or shall we go on to that?
We've got a lot of questions actually coming.
Okay.
How are we doing for time? Anybody?
Yeah. 10
10
minutes.
Okay, let's
Yeah.
go to questions. Do you want to
No,
talk
let's
about that?
just, let me go through the last bit quickly. This is a slide about misting in Germany, where they keep the cattle in, so they feed the cattle microbes, effective microbes, they put it in the water, they mist with it. The whole environment becomes a sort of a positive microbial kind of event. And then once again here with dairy cows, once again it's like, you know, how do you know your herd's healthy? Because your vet bills are low. So this is just some data about, you know, the amount of money saved per cow per year by feeding them on a diet of microbes. And then I think this is one of the last slides about nitrogen yield in there. And at one end it's, you know, water only. But as we come along and you mix microbes with biochar, you know, you've got a much greater increase of nitrogen locked in than microbes and what they call stone flour in Germany. That's just basically granite, ground up granite that microbes like a lot. But the best one, of course, is microbes, stone flour or granite powder, and biochar becomes a really strong source of nitrogen.
So reading this slide, I see a probiotic soil means you're able to capture more free nitrogen.
Absolutely.
Right, okay. Questions? Sophie, we got lots here. There's one, two, gentleman over there. Thank you very much. Is that the last slide? Yeah.
Thank you. This is a question for Jeff, really. I used to be a dairy farmer until a couple of years ago and was constantly trying to close this loop of health, healthy soil, healthy crops leading to healthy cows who were fertile and productive, and then their milk would be healthy, their poo would be healthy, which would then go back on the soil. And so, obviously, as a dairy farmer, you get very tuned into the nutrition of the cows as well. So, and we tried using humates, and we added it to the slurry, and we added it to the cow's diet as well, so humic acid, fulvic acid. Basically to do, I think, the same thing that you're trying to do with the microbes. So it's just to ask what your thoughts were on that, but also during years of feeding cows and getting sales pitches from people to try and sell you expensive additives for the cows. Yeast is a good one, and microbes to help rumen health and productivity. And I came to the conclusion that getting the right food for the bugs is more important than adding the bugs themselves. So it's just to get your views on that. And if these systems of the microbes going around a system in circles and adding health, the whole cycle becomes more healthy, and the result of that is healthier people eating healthy food. Do you envisage a point where it can be self-perpetuating? Do we constantly need to be adding microbes in at every stage to get that? How soon and how could we potentially get to this point where it's self-perpetuating, and how long before we get rid of all this badness?
Thank you.
Great question. Yeah, first of all, it's like when we're talking about microbes, we're talking about soil-based microbes that you can go and find a piece of land that's never been farmed, nothing's ever happened with it. You capture the microbes out of there. You get a microbial solution and it doesn't matter where in the world you go and find that, you'll always get the same varieties in the same proportions, which is a way of saying what you're really doing is you're going back to the origins of life, where it all started from. And from that microbial swamp soup, everything came. So what we're doing is getting that and then adding, and we don't screw around with it at all. We check it, we put it through laboratories, and we kind of know what's in there. But that combination in that just seems to be what works. Works for humans, works for cattle, works for land. So it's about getting that back into the food chain in any part. And it sort of depends, how long does it take? Just sort of depends about what other inputs you have, how degraded the soil is around there, the kind of health of what else you're feeding the cattle on. it's like, in my experience, whether it's a human or an animal, it actually takes quite a short period of time, if you get the dosage right, for them to be marked improvements in the health of the animal. And you know, that's a sort of given for us. You know, it's like, get it right and get it in the food chain. And it doesn't matter where you put it in the food chain. You can spray it on the grass, you can feed it directly to the cattle, you can put it in the slurry, wherever you want to do, as long as you get those microbes in the chain. Because what microbes are good at is closing the cycle. What we're not good at is closing the cycle. That's why we've got so much pollution and waste and stuff like that. But microbes naturally close the cycle. They'll do it, you know, within your farm, within your dairy herd. And then it spreads out from that. One of the main things that people say to us who start using microbes extensively is not only do your chickens get better, but the farmer gets better. So the farmer starts enjoying better health. They're not screwing around with all these chemicals all the time, things like that. So a number of people I know in Germany who've started using microbes started using them because the farmer was getting sick.
Any more questions? We've got 3 minutes left. There were a few hands. Sophie, please could, we have a lady here and then the lady over there. Let's take 2 questions, let's take the 3 questions and then we'll answer them.
Do I have to press? Does the increase in the microbes in the soil, you say it's beneficial for the farmer and the stock, is there anything that's been done to see how it affects wildlife?
Okay, thank you. We'll get the 3 questions, then we'll answer them because we're running out of time. We're going to be kicked out. The lady here with the glasses, please. And there was somebody over here.
Sorry, we have a little tiny micro dairy, and it's on an organic farm. And basically, we're required by the inspector, the dairy inspector, to put a sterilizing thing to cleaning the pipes. And I've been battling this because I would prefer to do it just with boiling water, or with. But could I get rid of this and with the microbe?
Maybe. And there was
Yeah,
one more
thank you.
question because we're going to be kicked out. The next speakers are here.
Okay.
Oh. Come on.
Hi there. Fascinating talk. We started the concept talking about human health and the concern about human health. I was shocked to hear the number of courses of antibiotics humans actually take. And until we sort that out, the actual food industry has got a lot to cope with.
Okay, let's answer the questions.
Okay,
Jeff can do those two.
do the first one. We sprayed some microbes in a field in Zambia, and the next morning when the farmer went down there, he said that the farm was full of deer, all the wildlife from all around had come and started grazing on that field. And the same thing is quite often we did a farm in Sussex. We sprayed the pasture there. And then after a while, he didn't order. And we said, why didn't you order some more? He said, we got young kids, and all the wild boar from the forest were coming grazing on our fields because, you know, animals naturally go to that microbial solution. They know what's healthy for them. So the answer is that microbes do a lot for wildlife. And then the second one, you can clean your pipes and clean anything with microbes. What microbes do by cleaning is they eat organic matter, and all dirt and stuff like that is organic matter. So that's just food for microbes. So if you run microbes through your pipe, then that's how they clean them.
And Maria, the gentleman.
Yeah, so on the question on human versus and animal health, I think it's important to remember the percentages of the consumption of antibiotics on a global level, and the majority of the consumption of antibiotics is within animals. So that's 70%, and that's a conservative number that I'm using, and 30% when it comes to human health. Now, it is also really important that that's part what's covered in the national action plans, is how our health professionals, i.e. your GP prescribing antibiotics to humans. And that is also should be included in the national action plans for different countries. And there is a big cultural differences if you compare here the UK, I'm from Sweden, and the prescription of antibiotics. If you go down to France, Italy, Spain, Portugal, and Greece, they have a much higher prescription of antibiotics and the ease with which you can get antibiotics. And that is an additional problem. I don't think you can say we need to solve this one first and the second one afterwards. And now I have to stop.
Now we have to stop. I'd just like to say, if anyone has any questions, come to the Soil Medic tent, which is A37, and there is come at any time, but there is also a specific Q&A session going on at 12 o'clock as well. And I'm sure that Jeff will be there to answer questions. Don't know about Maria. I think she might be coming to listen to some other talks here today. Thank you very much for your attention and questions.
Thank you.
Thank you.